Maths is so fun with Mr Nunn and my flowery shirt. What are we learning today? So today we're going to be learning about ratio. But first, my shirt. Now, it's been about 2 years since my last video, and I must admit I haven't been very good at buying flowery shirts. But for Christmas, my wife, the lovely, beautiful Mrs Nunn, bought me this Paul Smith flowery shirt. Very expensive. I believe it was on the sale. I haven't ironed it because I didn't have time for the video, so do excuse it, it's a bit wrinkled. Back to the maths. Okay, ratio. Ratio is very much about comparing two quantities of something together, or maybe comparing three quantities of something together. It's a little bit like fractions, but a bit different. We'll have a look at the link in a minute. Now, to help explain it, I thought this would be a great opportunity to use one of my favourite things. Anyone that knows me will appreciate this. It is chocolate buttons. Okay, let's say for example, for every 2 milk chocolate buttons that I've just got 1 white chocolate button. Let's show that. There's 2 milk chocolate buttons and 1 white chocolate button. Now, we would write that down as there being a ratio of 2 to 1 milk chocolate buttons to white chocolate buttons. And of course, altogether there, I usually put a total here. I've got 3 buttons. So for every 3 buttons, 2 of them are milk chocolate and 1 is white chocolate. So what would happen if I actually had 4 milk chocolate buttons? Well, let's have a look. I'm going to double my amount of milk chocolate buttons, but I also double, or multiply by 2, my number of white chocolate buttons. So there we go. So it's still a ratio of 2 to 1, but now we have a total of 6 chocolate buttons altogether. And you'll notice that the milk chocolate are multiplied by 2, the white chocolate are multiplied by 2, and the total is multiplied by 2 as well. Okay, now what would happen if I was very greedy and say for example I wanted 4 white chocolate buttons on that same ratio? Well, let's have a look. I'd have to double again the number of white buttons, and I would have to double again the number of chocolate buttons, milk chocolate buttons, and then altogether there I'd have 12. Okay, let's see how we can use ratio to solve problems. Got a problem here I've made up. Mr Nunn shares his sweets with Alan and Bert using a ratio of 3 to 2. That means for every 3 that Alan gets, Bert gets 2. Now, if Mr Nunn has 20 sweets, how many sweets will Alan receive? Interesting. So I'm going to start this by setting it out like this. I've got my ratio here, 3 to 2. There's Alan and there's Bert. Now that means for every 5 sweets, a total of 5 sweets, Alan will get 3 and Bert will get 2. Which from a fraction point of view, of course, means that Alan gets 3/5 of the sweets and Bert gets 2/5 of the sweets. Anyway, let's look at the question. If Mr Nunn has 20 sweets altogether, how many will Alan receive? Okay, well, let's have a look at this. In my ratio, the total of sweets is only 5, but I've actually got a total of 20 sweets. So I've got to say, what does a total need to do to get from 5 to 20? Now, I know that 5 times 4 equals 20. I'll put a little arrow there and multiply that by 4. So the question is, how many sweets will Alan receive? Alan has 3 under the ratio, but because the total is 4 times bigger, Alan's going to receive 4 times more. So Alan will receive 3 times 4 sweets, which is 12. Now the question doesn't ask this, but we can have a look at how many sweets Bert gets. Well, Bert again is going to receive 4 times more, which means he will receive 8 sweets. And just as in the ratio 3 plus 2 equals 5, the total, you should find the number of sweets that they receive, 12 plus 8, will equal the total number of sweets that Mr Nunn had. So the answer to that question, of course, is that Alan will receive 12 sweets. Okay, so I've got a problem for you now to try at home. Mr Nunn has a ratio of 2 to 1 milk chocolate buttons to white chocolate buttons. That means for every 2 milk chocolate buttons, there's 1 white chocolate button. If he has 18 milk chocolate buttons, and here they are, just below the problem, how many chocolate buttons will he have in total? Okay, have a think about that. Have a think about how we did the last problem and see if you can solve that at home. And freeze. So, hopefully you've solved this problem, or if you haven't, let's give it a go. Okay, just to recap, we've got 2 milk chocolate buttons to every 1 white chocolate button. And that means that if we've got 3 buttons in total, 2 of them are milk and 1 is white. Now that would be easy if we had 2 milk chocolate buttons, because we'd know that there'd be 3 buttons altogether, but we haven't. We've got 18 milk chocolate buttons. So I've got to say, what do I do to go from 2 to 18? And of course, if you know your 2 times table, you'll know that you multiply 2 by 9 to get to 18. So let's do multiply by 9, and that works. Now, if we wanted to find the number of white chocolate buttons, again, we'd have to use the same multiplier there. So we would multiply 1 times 9, and we would have 9 white chocolate buttons. Ah, yummy. There you go. So, again, with the total, you just have to multiply it by 9, because you had to go from 2 to 18, which was multiplying by 9 on that side. So we know that the total number of buttons altogether is 3 times 9, which is 27. And we can prove that by adding 18 buttons to 9 buttons, which equals altogether 27 chocolate buttons. Yes. Wow, all that using chocolate buttons has made me hungry. So we're off to eat some chocolate buttons, and I'll see you next time. But in the meantime, maths is so fun with Mr Nunn and my flowery shirt. That's enough today.